Hi, this session is presented by the Kubernetes VMware User Group. This group is about running all forms of Kubernetes on the VMware infrastructure platforms from a user perspective. I'm Steve Wong, co-chair of the user group. I work on Kubernetes and a few other open source projects as an employee of VMware. Today, I'm joined by Myles Gray, the other co-chair. Myles is Senior Technical Marketing Architect in the Storage and Availability Business Unit at VMware. We'll give contact information and a link to the deck at the end. Here's the agenda. Myles is going to start with a really quick summary of what the cloud provider and storage provider are. We'll move on to address some recent changes and planned changes. Those topics relate to running Kubernetes on the vSphere platform, but we're also going to talk about running Kubernetes on the desktop hypervisors, Fusion and Workstation. Finally, we'll wrap up with some links to resources. Hopefully you'll like the talk, and at the end, I'll provide details on how you can become a member of the Kubernetes VMware User Group, where we host ongoing discussions on subjects like the material in this talk.
Thanks for that, Steve. So, like Steve said, I'm going to talk to you about the vSphere cloud provider, the updated out-of-tree cloud provider, and the container storage interface. So we'll cover off the vSphere cloud provider first, and cloud providers are a concept that sort of makes Kubernetes cloud native. It provides an abstraction layer between the APIs from the underlying infrastructure, whether that's vSphere or Google Cloud or Amazon or what have you, and the primitives that Kubernetes understands. So it means that Kubernetes doesn't have to have core platform logic built into it in order to communicate with the underlying platform to ask for resources and that kind of thing. So the vSphere cloud provider and the cloud provider interface, the in-tree and the out-of-tree, what they really do is they allow for labeling and locality for virtual machines on top of vSphere, but in a way that Kubernetes can understand. So you can put things into zones. It really sort of ties the underlying infrastructure, so the VM concept, into the Kubernetes layer. So it'll apply labels into particular nodes in Kubernetes based on what their VM ID is and that kind of thing. So the cloud provider vSphere is an updated out-of-tree version of the vSphere cloud provider. And the vSphere cloud provider is something that's known as an in-tree cloud provider. Those are all being sort of phased out by about Kubernetes 1.20, 1.21. The migration timelines change a little bit, but I think it's 1.20 at the minute. And basically the idea is the Kubernetes maintainers want to remove all of the in-tree cloud providers, because what it does is add dead code into the code base. It opens it up to security vulnerabilities. It adds bloat to the core Kubernetes binaries that doesn't need to be there. And it means that if there are changes that need to be made to a cloud provider, the vendor for that cloud provider has to make changes to the core Kubernetes code base rather than just updating their own individual plugin, which you can appreciate. If there's a bug that you want to fix, that means you have to upgrade your entire Kubernetes platform. So not really a great solution. So they've pushed all of the vendors, including ourselves, to creating out-of-tree versions, so more of a plugin type architecture. So that's what I'm going to talk about. I'm going to talk about the VCP, the CPI, which is the cloud provider interface, which is the out-of-tree version of the VCP, and the CSI driver itself. So we'll start from a storage perspective, because storage is sort of my thing. And we've already talked about the VCP, and basically it was a minimum viable product. It was an in-tree cloud provider that allowed for dynamic provisioning of storage on Kubernetes. So if a pod was scheduled and it required a 100 gig volume, the vSphere cloud provider would take that call and translate it into something that vSphere would understand. So it would essentially just create a 100 gig VMDK and mount it into the appropriate Kubernetes worker node so that that pod can access some storage. So that was all fine, but like I say, it was a minimum viable product. It had kind of a hacky way of deploying storage, and basically what it did was it would create a shell VM that had, nothing in it other than a VMX file and a VMDK. It would then detach the VMDK, delete the VM, and then reattach the VMDK to whatever the target VM was. So I think you can appreciate that there's some work that's being done there that didn't really need to be done. It also led to an interesting problem, and if you've ever worked as a sysadmin on vSphere systems, if you detach a VMDK from a VM, there's no real easy way to discover those. So they become orphaned and they just sit on the data storage consuming space, but they are hard to identify, that there's no mapping to them. So we saw this move from in-tree to out-of-tree as an opportunity to rewrite that integration in its entirety. Like, we basically just went from scratch and we used a completely different backend that doesn't have some of those inherent problems. So that's what we sort of released with vSphere 6.7 U3, something called the CNS Platform, which is Cloud Native Storage Platform. And it has basically the same features as the vSphere Cloud Provider, but in a much more supportable, much more scalable manner. So you've still got your dynamic provisioning of volumes. So if your applications require storage, they can still request that and have it assigned automatically. There's no need to have a developer talk to a sysadmin to get stuff provisioned. And frankly, that's just not the way stuff works in this world. So having dynamic provisioning is a must. That VM provisioning workflow I talked about, where it created a VM with a VMDK attached and threw away the VM. Clearly, a lot of API calls and a lot of functions going on there that didn't really need to happen. So we changed the backend from that, what we call just the legacy VM provisioning backend, to something called first-class disks. And first-class disks are really nice because they don't have this orphan storage problem. If you unmount one of these first-class disks from a VM, we still track where it is. We still track how much storage it's consumed. You know where it lives on the file system, all that good stuff. So even whenever you scale out an application, say a stateful set, and you scale it back in from, say, 3 to 2 nodes, it'll keep the disk there. The first class disk will still exist, persist. It will still persist. That's the point of it. But we won't lose track of it. So the next time it goes to scale out, say from 2 to 3 nodes, it'll automatically take that volume and remount it back in, and then the application can do a delta sync on top. So it removes some of the challenges around operationalizing it. In addition, we added a UI into vCenter for all this stuff. So whenever you get a dynamically provisioned volume, all of those volumes show up in the vCenter UI, so that if you're a developer, your sysadmins can help you in debugging things. If you give them a PVC ID, they can just paste it into our UI and it'll show them, right the way down to the physical tin, what disk that volume actually exists on. So a lot of the refinement and feature additions that we made were really around making this more scalable, making it more operationally viable. So that was our release with 6.7 U3. And then in 7.0, we continued on that architecture and we added a few more bits and pieces in there. So if any of you are familiar with vSphere storage, we added support for basic vvol primitives. So if you want a block volume, that is to say, if you want a read-write once volume in Kubernetes, you can now use VMFS, NFS, vSAN, or vvol. So all storage types for vSphere are now supported. In addition, we had quite a few requests for read-write many volumes. So if you have a vSAN data store, we can now automatically provision NFS file shares for you, just dynamically the same way we would for read-write once volumes, and they will get mounted into however many pods and worker nodes you assign that single read-write many persistent volume to. So the big thing was the file-based volumes based on vSAN. Like I said, vvol support as well. But we've also added per persistent volume encryption support using vmcrypt. So you can ask for a volume to be provisioned using an encryption storage class, and that will encrypt those volumes, and they're rekeyed whenever they get moved to another VM. So if you have a node failure and it gets moved to another VM, that volume will be rekeyed so it can be reread by the target VM, which is quite nice as well. And we have persistent volume snapshots. Now, I'll highlight this isn't the CSI snapshot feature. We don't have interop with the CSI snapshot API yet. But this is a plugin for Velero. So if you use Velero for backup and restore of your Kubernetes applications, we have something called the VADP plugin for Velero. And that will take vSphere level snapshots of the persistent volumes before the data is read off them to ensure atomicity of the data as it's being read off, to ensure that it's consistent when you back it up so that whenever you restore it, it will be at least crash consistent. We also added a first pass at volume resizing, so we can now actually support offline volume resize. So you would essentially remove it from your pod, delete the pod, change the specification of the PVC, it'll automatically expand it in vSphere, and then you can reattach it to your pod. And we've added support for a mixture of tooling as well. So if you want to use Wavefront, you can use Wavefront. But we realize that almost everyone here uses Prometheus. So we added native Prometheus exporters into ESXi, as well as created a bunch of Grafana dashboards for those that actually expose those metrics and tell you how to use them as well. So if you have Prometheus in your environment, you can now use that to scrape metrics from ESXi as well directly and have your applications react to changes on the underlying infrastructure. So if we take a little look here just to do a brief sort of 101 of how this actually works, everything you see in orange here is vSphere, everything in blue is Kubernetes. So you've got your vCenter installed on your vSphere infrastructure, and CNS is just a daemon that runs inside vCenter. So when you install that, it's just automatically there. So the first thing you do is you create your SPBM policy in vSphere. And if you're not familiar with vSphere or SPBM policies, it's essentially just a storage class. Like, they're basically identical concepts, but an SPBM policy allows you to specify things like, how many copies of this data do you want? Where should it be located, on what site, that kind of thing. So you create your SPBM policy, and then you create a Kubernetes storage class that points at that SPBM policy. So super simple, they just related by name. Then we've got our CSI driver, and the CSI driver is what does the translation between the Kate storage class and the SPBM policy. So whenever a volume is provisioned, that is how vCenter and vSphere know in what manner to create that volume and where to mount it into which Kubernetes node and then what pod. So you've got a Cassandra deployment here, and it says I would like a 100 gig volume from this storage class. So that storage class, if you look at how that's constructed, there's a provisioner, and that would say this is the vSphere CSI provisioner. So it says, okay, well, I'll hand this call off to the vSphere CSI provider. It looks at that request and says, okay, we're going to send this to the vCenter that I'm registered with. So it sends it to the vCenter. CNS looks at the request and says, okay, this is a read-write once volume, and it requires this SPBM policy. So it sends that to the SPBM engine, and then it just creates that volume based on what the policy said. So it will create 2 copies of the data, mount it up into the appropriate Kubernetes worker node, format it with a file system, and mount it into the container. So end to end, that is completely automated after you create the Kubernetes storage class, which is really very nice. And one thing I want to mention here is there are customers and people out there who have been using Kubernetes for a while that will have volumes provisioned through the vSphere cloud provider. And you'll have to do a migration at some stage from the vSphere cloud provider to the CSI driver. Because like I said, the Intrigue cloud provider is going to go away, and the CSI will be the new way of doing things. So in the new version of Kubernetes in 1.19 and the CSI driver, we are adding beta level, or what we call beta level support for VCP to CSI migration. Now, basically what this does is it allows you to have the vSphere cloud provider installed in your environment. You can then enable this migration feature with some feature flags in Kubernetes 1.19, and then you can install the CSI driver. And what it basically tells the CSI driver to do is to just intercept all requests that would go to the VCP and just provision them through the CSI instead, or service them through the CSI. In addition, it will actually change the backend disk type from just a standard VMDK to a first-class disk, so that whenever you are importing all of these volumes, you get all of the nice new UI-based tracking and all that stuff that comes along with CNS as well. So the upgrade would actually be transparent to the application. You don't need to change any of the application manifests. We basically just intercept all of the calls that would go to the VCP via like a webhook shim layer, and they get pushed into the CSI instead. So we just take over all of those calls. So this is really nice from like a day two perspective. Whenever you are upgrading your K8s clusters in future, you'll be able to just take your existing volumes and import them into the CSI driver so that they get automatically included in the vCenter UI, which is really quite cool. And we're just going to take a brief look here through some of the recently added features in the vSphere Cloud Provider before I hand it back to Steve, and he's going to take you through desktop hypervisors. So just real quick, we're going to hit off the new things here, and then you can click on the individual links with the deck afterwards. So we actually have NSXT based load balancers getting added into the cloud provider. So if you specify a service type of load balancer, we can interop with NSX directly and ask for those to be provisioned, which is really quite cool. Additionally, we're moving from like an INI type config to a YAML based config, just because, you know, that's kind of how things work these days. We are updating the cloud provider interfaces image account to be a non-root account, which I'm sure you'll agree from a security standpoint is a good thing to do. And just adding a bit more robustness to the whole zones and regions labeling. We're looking at, or we are adding folder and resource pool traversal for those features as well. So if you are using zones or tags, it'll now be able to traverse all of the resource pools or folders under that environment and figure out where stuff actually lives. And like I say, the rest of it you can read through in your own time with the deck afterwards, and you can click on the individual pull requests and see how those things actually work. So I'm going to hand it back over to Steve now, and he's going to take you through Kubernetes Desktop Hypervisors.
Thank you, Myles. I'm going to move on to running Kubernetes on VMware Desktop Hypervisors. The Desktop Hypervisor was actually VMware's first product back in 1991, and it was first hosted on Linux. This first generation of products was the origin of the server class hypervisor products. Even though VMware is best known in data centers, the desktop hypervisors for Linux, Windows, and Mac are installed on millions of computers. The Fusion hypervisor is the version for Mac, and like Workstation, it's known as a Type 2 hypervisor, meaning it runs on an OS rather than directly on bare metal. It's also worth noting that these desktop hypervisors implement virtual networking to allow creation of multiple networks connected to the VMs they host. This shows the latest versions of the production products, but it turns out that a newer tech preview beta is also running now. Participation in the beta is free, and there are player versions of these desktop hypervisors also available for personal, non-commercial use. I'm going to show a Kubernetes install using the tech preview just because that's what I've got running on my laptop. But pretty much everything I'm going to show applies to other recent versions of these desktop hypervisors as well. The new 20H2 version in Tech Preview has support for running containers directly without composing a VM. The experience is not unlike Docker at a command line. You have push, pull, run using a CLI, in this case named vcuttle. The difference is that these Docker and OCI compliant container images run in the hypervisor in a lightweight fashion. The Kubernetes in Docker tool, is not currently integrated into this tech preview CLI, but I'm told that developers are pursuing this. The top line here shows the download links for getting the production releases of the desktop hypervisors. And by the way, the Fusion hypervisor for Mac, version 11.5.5, is already out with this container support. So if you're running 11.5 Fusion, you can upgrade to 11.5.5 right now to get the container support. The next line here has links to the free Tech Preview Beta. And a warning, if you use the earlier Tech Preview Beta that was out at the beginning of the year, uninstall it before moving on to the newer version. Also, be careful about using Google to find this beta, because the older version tends to show up first in the search results, just because a lot of blog posts got out talking about it. So I'm going to show a demo running Minikube with a series of screenshots rather than as a video. If this had been a physical conference as originally planned, I would have done it as a live demo. But since we're going to do it online, it can't be live anyway. And I decided that the screen content snaps suffer less from bad internet, and also allow cut and paste directly from the slides in the deck if you choose to follow along later at home. So I'm going to show this demo on Windows instead of Linux for a few reasons. I'd rather show the more disruptive environment, and Windows simply tends to get lighter coverage in the blogosphere. Kubernetes continues to open up Windows container support, and I've been running into a lot of Windows developers who are struggling to learn the new world of Kubernetes. So I wanted to be inclusive and help people get a bridge from those millions of Windows laptops into the world of Kubernetes. If you're on a Mac or Linux machine, don't fret. It's very similar to what I'm about to show. Mostly the difference is that you can cut out a few steps. So start by downloading the 5 items listed here. If you're watching from the recording, these links are to specific versions that probably have a shelf life of a month or two. So if this is an older recording at the point you catch it, look for newer versions as needed. In a few cases, you could flip the order of these installs, but this is what I tested. If you're on a Mac or Linux, you can probably have get already, so skip that step. It doesn't likely make sense. The summary here is, I'm assuming you've already downloaded it. From your collection of downloads, start by installing the hypervisor, then Golang, get. Finally, build a driver from the Golang source, install kubectl, and then Minikube. These downloads are installer packages, so they're pretty simple to figure out. I'm not going to make you watch step by step with these installs. Just find the installers that you downloaded and install them in the order here. You should be fine. Next, we're going to configure Minikube. The effect of these configuration settings is to specify the VM that Kubernetes is going to run in. The settings I'm showing here are generous. I did these big to allow enough to run pretty demanding things, such as installing and running an Istio service mesh. You could easily cut these in half if you have a small laptop and you're only going to run a few simple apps in Kubernetes. By the way, I show an optional step here because I'm changing the default network CIDR, and this change is going to require some additional setup in the Workstation hypervisor that I'll get to in a moment. I'm doing this simply because Most Minikube usage examples that you find out on the internet use the 192.168.99 CIDR range. And I wanted to make it easy to cut and paste out of any examples you might find off the internet. So do the config steps shown here. But when you're done, don't close the command prompt that you do this in, because we'll be back to it shortly. You'll follow the steps to configure each of these settings one at a time, and that final step of Minikube config view just echoes back your configuration so that you can verify that you didn't have any typos. Now I'm showing the configuration of the VMware Workstation Hypervisor. Like I say, it comes with virtual networks. There are some created by default. You can create more if you need them. But what we're going to do is change the IP subnet that is being used by one of these pre-configured networks. So we start by opening the Workstation UI, and we choose the virtual network editor from the Edit tab. By the way, you're going to need to have admin rights to your machine in order to edit these virtual networks successfully. Otherwise, it's a view-only scenario. You start by hitting the Change Settings button on the lower right, and this triggers escalation to invoke your admin privilege. Then you change the subnet prefix to 192.168.99, and then finally press the DHCP settings button. This shows the dialog box that's going to pop up. We're going to assign a block of IPs to DHCP and keep the rest in reserve. So in the portion of the dialog box circled in red, change the DHCP octet range to hand out addresses from 128 to 254, and then hit the OK button. Now it's time to go back to that command line prompt and start Minikube, which is going to be a VM that will be running Kubernetes. The Minikube start step is going to take a minute or two. How long it takes exactly might even depend on the speed of your internet connection. When you trigger this Minikube start, you're going to see log output as the VM is composed and started, and the components are pulled, installed, and run. The VM is going to be underneath the .minikube/machine/minikube directory inside your home directory on Windows. And later you can add that minikube.vmx file to your workstation inventory using the File Open menu if you want to see it in the workstation GUI. After the command line shows done with an exclamation point, you can verify using Minikube status, and the kubectl CLI with kubectl version is shown here. When this is complete, you have Kubernetes running inside a workstation hosted VM. We'll move to a moderately advanced demo now, but you could do whatever you want. Minikube starts pretty lightweight, but I'm going to turn on some actual optional add-on features since I gave this VM plenty of CPU and memory to allow this. We're going to deploy a load balancer, something you might need if you're going to play with service mesh or interact with the outside world. We're also enabling the Kubernetes dashboard. So do the command line steps shown here, and you should get the results shown in blue. When you do invoke the Minikube dashboard command at the command line, this will open up a browser windows with the Kubernetes UI. The MetalLB load balancer is capable of issuing IPs from a pool like an IPAM, but we need to configure it in order to specify the IP address pool that it issues IPs from when it provides load balancing services. This has to be a different range from the range we assign to the DHCP server. Those ranges are issued to VMs as opposed to the MetalLB load balancer issuing IPs to Kubernetes hosted services. On the menu on the left inside the dashboard, enable showing all namespaces, then go down and choose config maps and edit the config map that's associated with MetalLB. We're going to want to alter that config map as shown in the thing circled in red to assign the IP range ranging from 192.168.99.105 to 120. Now we're going to deploy a service, and this is the Hello Minikube service example that comes straight out of the Minikube docs. We use kubectl to create a deployment of a web service as shown here. Then we use kubectl expose to create a load balance service and make this web server publicly accessible. After this completes, you can find a link to the service in the dashboard, or you could also get the URL from the command line. I'm not going to show it here, but if you do this later at home, a hidden slide in this deck shows the steps to clean up the service, the deployment, and even the Minikube VM. So this content is brought to you by a Kubernetes user group. And if you're using Kubernetes on vSphere, I encourage you to formally join this group. We have a meeting each month where we discuss tutorials and best practices. The agenda is user-driven, so members are encouraged to nominate presentation and discussion topics, including discussions of feature requests. We've got two user tech leads, Bryson Shepard and Joe Searcy, who helped get this group started, but they couldn't be with us today in this online presentation. We're looking forward to growing this group with a diverse set of worldwide users. The group is also running a Slack channel, which is a great place to ask questions and meet other users. It's a good place to bring up vSphere specific topics, but if you want to talk about Kubernetes in general, perhaps there is also a Kubernetes user channel, which might be more appropriate for really generic questions and discussions. It's also, the Slack channel is also a great place to reach out to meet code contributors and documentation contributors. So the next user group meeting is going to be September 3rd in the North American time zone. You can go to the Kubernetes community calendar link shown here to get a conversion to your local time zone and to add it to your calendar. You can become a group member by joining the mailing list that's shown in the link here. And finally, here's a link to the group's Slack channel. So Myles and I are going to hang around for Q&A. There's a link at the top that will get you this deck. The slide also shows our GitHub IDs. And if you're watching the recording later, you can ask questions on the user group Slack channel. Thank you, and I hope to see you in a future meeting. At this point, I'm going to turn it back over to the CNCF moderators.